that interface. The synchronization parallelism class is used to create active objects that implement the divide and conquer technique in parallel using a process tree. The quicksort class creates instances of the problem to be solved using a sequential algorithm, in this case quicksort. This class must implement the interface. The solution quicksort class provides instances that contain a solution to the sorting problem, while the testdbpar class is the main program. In this model, the input data provided by the user through the manager object flows from root, which will be a dynamically created state object, to which a slave object is associated in order to have the user sequential algorithm that solves the problem and repeats itself. This procedure of creation of 3 nodes is done until reaching the state leaves and vice versa, backtracking as recursion does. Peer nodes run in parallel. The initial or root stage of the HLPC will obtain the final solution, which is the completely ordered data set, and will be sent to the collector object, which in turn will deliver such solution to the manager for completion and deliver it to the user. The execution of the 2 models proposed in this work, PDP and HLPC divide and conquer, were carried out on 2, 4, 8, 16, and 32 dedicated processors. The left graph shows the execution time in seconds of both the PDP and the HLPC proposed. The right graph shows a comparison of the speedup found and the upper bound of Amado's law at the magnitude of these accelerations. Conclusions. We have presented the parallel design patterns PDP model and the high-level parallel composition CPANS model as 2 proposals for structured parallel programming models. Both proposals generate abstract construction that contains the parallel structure that communicates to the different processes, generated in each model according to an algorithmic design technique and a common communication pattern for the semi-automatic parallelization of a sequential problem provided by the user, thus as the input data. For both proposals, we showed the particularized development method in solving the ordering problem with quicksort using the divide and conquer technique. Both proposals can be used by programmers without the experience in the development of parallel applications to obtain efficient code, programming only the sequential part of their applications and using the parallel structure of the model described as libraries in their codes. We show the performance analysis, execution times, and acceleration of the proposed model when used in the solution of the ordering problem with quicksort. In this case, a 32 processor parallel machine was used. Thank you very much, and if you have any question, feel free to do it. Thanks.
Me parece que tu micro está desactivado, Emilio.
Sorry, again. I am so sorry. Thank you for advising me. Sorry, everybody. I had my microphone off again. Now it's time for questions. Is there any question, please? Okay. If there are no questions, I will ask one question. It's very easy. You have proposed 2 different approaches, and I would like to ask you, for a real application, which one would you recommend and why? I will translate him into Spanish because he has asked me to do it this previously. Has hecho 2 propuestas. ¿Cuál es la que considerarías más apropiada para una implementación real y por qué?
Bueno, la segunda propuesta, la propuesta del CPAN, yo creo que es la mejor porque ha dado mejores rendimientos en cuestiones de aceleración comparada con la PDP. Yo
Very
creo
much.
que esa propuesta es la que se
I
utilizaría
will
para
translate it
resolverlo.
in a moment. Yes. Okay. Yes. Sorry, he has asked me to translate now. Yes. The answer is that he would prefer the second one because the performance is more interesting, especially according to the acceleration. Then this is the selection he will do for a real application. Okay. Thank you very much. And then let's go to the next paper, next work, which is titled, just a moment, a conversion framework of the continuous modeling languages based on Untitled 4. I don't know whether are here any of the authors.
It's me. Thank you.
Okay, thank you. Do you have the presentation to share it? Yes.
Good afternoon, professors and colleagues. It is my honor to be able to introduce my work here. The topic of my report is a conversion framework of the continuous modeling language based on Untitled 4. Next, I will introduce my work from following 4 aspects. First, introduction and related works. Second, conversion framework based on Untitled 4. Third, experiment. Fourth, conclusion. Part 1, introduction and related works. In recent years, model-based systems engineering has gradually become the main solution for industrial complex product system modeling and design. MBSE enables engineers to use domain-based information interaction in system engineering to replace traditional document-based information interaction. This distributed modeling, but integrated management solution can greatly improve the work efficiency of large-scale projects. The picture on the left reflects the general working process of MBSE. In MBSE modeling of specific physical objects, a large number of modeling and simulation software will be used. Among them, the modeling of continuous physical objects is an important part of it. For continuous system, the common modeling method is to establish a system of differential equations or partial differential equations, and then use a solver to solve the equations to obtain simulation results. Due to the differences of modeling languages, the models established by different languages can only be reused within the language, which cannot be reused among languages. Therefore, if the conversion between different modeling and simulation languages can be realized, some established modules can be reused. So this paper proposed a conversion framework of the continuous system modeling language based on Untitled 4. It is hoped that this problem can be solved in a certain extent. Regarding code-to-code conversion, predecessors have done a lot of work based on the traditional grammatical rules. There are mainly 3% on the left. The general idea is to convert the input text into an intermediate representation with a relatively low level of abstract dependency, and then output it. Recently, some researchers have used the statistical method, machine learning, pointer networks, and other methods to try to convert the code to the right, but the accuracy cannot meet the high requirements, and there are some unpredictable structure errors. Part 2. Conversion framework. The conversion following chart is shown on the left. The whole conversion process mainly includes 3 main steps. First, Lexer pressure and concrete syntax tree generation. First, reconstruction and conversion based on distributed multiple visitors. Third, the text output in depth first traversal mode. The first step is lexical analysis, mainly with the help of Antler 4 tools. Antler, which named another tool for language recognition, is a powerful parser generator for reading, processing, extracting, or translating structured text or binary files. It is widely used to build languages, tools, and frameworks. From a grammar, Antler generates a parser that can build the work parse tree. In this step, we use the Becker's normal form of modelic language as the input of Antler 4, and we can obtain the interference file for generating the parse tree. It is convenient for us to streamline the structure of the grammatical tree. The second step is to transform the syntax analysis tree of the input language into an abstract syntax tree of the output language. Here is an example to show the difference between text phrase tree and abstract syntax tree. Here we use a form of multiple visitors to operate the syntax tree through the interference file generated in the previous step. Since the behavior of multiple visitors is independent, complex conversion tasks can be disassembled. In this step, it is also necessary to construct an abstract syntax tree of the output language according to the grammatic rules of the output language. This is abstract syntax tree, and this is the detailed code. And this is the second step is to transform the syntax tree like this into an abstract syntax tree of the output language, like this. And third step, through depth first traversal and output arrangement of specific node for text output. Here you need to consider the grammar of the target language in combination with actual situations. Sometimes an input file may be correspond to multiple files in the target language. And then we apply the bound framework in the conversion from modelic language to TAR language and conducted experiments. Here is a simple understanding of the done conversion process through a screen recording. On the left is project files, including some interference file and the visitor files, and this is Becker's normal form of Modelica. We open here we will open the Modelica module library code to copy and paste. Then the corresponding X language code will be output in this output box. Let me wait for a little time. Yes, like this. The left is Modelica's file, joint demo, and the right is child languages file. This is a user interface. Here we compare the amount of code in the two languages and recorded some conversion time, and found that the performance of the converter needs to be improved, especially module classes with external references. Here, module classes with external references, it will spend a lot of time to convert. And then we build the same circle module with Modelica, and then converted it into X language code through a converter. As the same simulation results were obtained, which verifies the effectiveness of the conversion. Conclusion. We have some contribution. We show a continuous modeling language conversion framework based on Untitled 4, and we provide support for some imagery modeling and simulation language such as X language. Of course, we does not expand the conversion of discrete part of Modelica. In the future, we will optimize the converter structure to make it more universal. Use the conversion framework to promote it in other model languages. That's all. Thank you.
Emilio, the microphone.
I am so sorry again. Today is closed automatically. I don't close it, and this is the reason why I forget to open it again. I don't know why today is closing it. Okay, it's time for questions. Is there any question? Okay, if there are no questions, I have a very easy one. I think it's very interesting, this application, this translation, and I realized that you have validated with examples in an academic way. Have you tested it in some company, in real applications, or up to now only to academic models?
Based on the needs of production and life, the modeling and simulation of continuous system have a very wide range of requirements and applications. In my this paper proposed a conversion framework called continuous system model language based on Untitled 4. And I only applied it into the Modelica to X language conversion experiment. In the future, maybe I would do more experiments. Yeah.
Okay, thank you very much. Very interesting your work also. Okay, then let's go to next speaker and next work. Time to idle control variate performance in the single queue case. Are here any? Okay, we have here. Did you prefer me to share the video?
Yes, if there is any problem, I go out and came back within Windows.
Or we can also ask to Antonio to share it, because I think he can do it better than me. Okay, and no. Well, I can try. Okay, just a moment.
Oh, sorry, Emilio. I had my microphone closed.
Okay, the same question. Okay, yeah. Thank you, Antonio.
No problem. I'm going to open it.
Okay.
Thanks. Okay, and now share.
You should see it, right?
Perfect. Perfectly. Thank you very much, Antonio.
No problem. Enjoy.
Hello, my name is Andrés Suárez, and I'm going to present our performance study of the time-to-idle process used as a control variate in the single queue case. This process, the time-to-idle process, was developed for the case of having several queues attended by only one server using a polling discipline. Now, in the single queue case, we will be able to compare its performance with respect to another two control variates that are the inter-arrival time and the service time. In the single server queue, we will model the behavior of the clients through two stochastic processes. The one modeling the inter-arrival time of the requests, and the one modeling the service, the amount of service requested by each one of them. In this queue, we are interested in studying the queue waiting time. More precisely, we are interested in estimating the mean value of the queue waiting time, and usually this is done through the average of several of its random variables. The control variates method consists of, instead of directly using the random variables W, using a modified version of them where we are subtracting part of the variation, given that we have another process, a control process, strongly correlated with the queue waiting time and of known mean value. This way we will average Y instead of W, and we will have a smaller variance. How the time-to-idle process is defined? If we observe the evolution in time of the system, we will see tasks arriving, and after a time waiting in the queue and afterwards being served, these tasks depart the system. If we focus on the state of the server, there are going to be two types of intervals: the ones where the server is busy and the ones where the server is idle. This idle time we are going to divide in subintervals, each one of them belonging to one request. So how much share of idle time corresponds to each request? This is what we define as L. Time to idle is defined as the time needed to accumulate an L amount of idle time. This process has a known mean value that coincides with that of the inter-arrival time. The problem with the time to idle is that its random variables are not synchronized in any way with the arrivals or departures of the requests. This problem is solved in part using the batch means method for the estimation of the mean waiting time. There are several ways to implement it. We have done it looking for, in the central batches, the nearer arrival with respect to the starting point of a time to idle random variable. Now we are going to see how the time to idle used as control variate compares with the service time or the inter-arrival time in the most simple cases. First, in the DM1, where inter-arrival times are deterministic, so the same value always, the service time is exponentially distributed. In this case, we see how we can get a significant sample size reduction in order to comply with a confidence interval requirement of almost half. Almost half of the sample size is needed if we use the service time as a control variate. If we use the time to idle instead of the service time, we get, well, a good reduction, but something like 9 percentage points below what the service time obtains. In the case of the MD1 system, that is inter-arrival times exponentially distributed, constant service times, we see something similar to the service time in the DM1 case. Almost half of the sample size is needed to comply with a given confidence interval requirement when using the inter-arrival time as control variate. This time to idle is again something like 9 percentage points below what the inter-arrival time gets. This parallel behavior in the two systems let us hypothesize that perhaps the time to idle lower sample size reduction can be due to the synchronization problem. If we see their behavior in the MM1 case, that is, inter-arrival times are exponentially distributed and the service times are exponentially distributed too, we see how the sample size reduction that any one of them obtain used individually is lower than half the sample size reduction that they obtain in the simple cases MD1 and DM1. Nevertheless, the time to idle get something quite similar with respect to what it obtained in the two previous cases. Concretely, this point is almost the same that it obtained in the three systems. Of course, in the MN1 case, the service time and the inter-arrival time may be used together and they will get something like the sum of the two sample size reductions. In this case, the time to idle would be something like 5 percentage points below what they can obtain when used together. We have seen how the time to idle control variate gets a good sample size reduction, but something like 9 percentage points lower than the simple control variate in the simple cases. This gap is smaller in the MM1 case, and this leads us to think that other synchronization approaches may close this gap. And that's all.
Now, yes, my microphone is open. Okay, thank you very much for your presentation. And now it's time for questions. Any question? Okay, I got just one very fast question. You have said in your last sliding that as future work you will analyze other synchronization. Which one could be, for instance?
Okay. And now, as it is implemented, we keep batches independent one of another. The ideas, we have several. The ideas to try are let them collide in some little points, but keep each one more synchronized with one another. The one with the waiting time and the one with the time to idle.
Oh.
Because it's interesting how it can capture quite a lot of the variance of the waiting time. It's well, academic interesting.
Okay, thank you very much. Is there any other question? No more? Okay, thank you. And then let's go to next work. Simulation-based sensitivity analysis methods and software tools.
Good afternoon, everybody. So thanks, Mr. Chairman, for introduction. So I have also pre-recorded video as was required. So I will try to share from my computer, right? So, okay. Oh,
okay, when sharing, you have to close it and share it again. And when sharing, there is a window in which a button asks for sharing the noise, the voice of the computer or something like that. In the up left, up right corner.
Okay, can you see it now?
Yes, we can see it, but we can't hear. Then you have to close it and share it again. And when sharing, selecting the option of sharing the voice of the computer, the noise, which is in the upper right part of the screen.
You mean my voice now at Teams, right?
Yes, your voice, yes, but not the voice of the presentation.
Yeah, sure. Well, so now.
Sorry, maybe I can help you. So you should turn on your microphone, otherwise we cannot hear you.
Mm-hmm.
Hello, Novák? You turned off your microphone.
You have to turn it up.
Okay, please turn it on.
Yes, thank you.
Perfect.
Okay, now, yeah, so I'm here. So maybe you can run it from your side?
Yes, but if you just click on the button next to the microphone.
Yeah, sure.
This one, just to close the sharing.
Close sharing.
Perfect. Now, if you click again,
Sure.
you should see an option include audio of your computer.
Yeah, there is a window.
There is a sort of button to include the audio of your computer, and then you can share like you did.
In the upper right part of your
include
screen.
Audio. Ah, okay. So it's
Yeah.
here. Oh my God. Okay. Yeah. So.
Thank you, Antonio.
Now I go back, right?
Yeah.
So yes. I start to share.
Thank you.
And put the whole screen, right?
Yes.
And now my pleasure to present our work on simulation-based sensitivity analysis. I will speak about techniques and software tools we developed. My name is Drahomír Novák, and I'm coming from Brno University of Technology, Institute of Structure Mechanics. So, outline of my presentation is first I will explain some motivation for sensitivity analysis based on small sample simulation. For that, I need to explain uncertainty simulation based on Latin Hardloop sampling. This technique has been implemented in free software where statistical sensitivity and reliability analysis are implemented. Well, the focus is on simulation-based sensitivity analysis. That we are working with three techniques: non-parametric rank order-based sensitivity, covariance-based sensitivity analysis, and also input perturbation-based sensitivity analysis. Finally, I will show one interesting selected practical application, real-world application, concrete roof girders beam. So, motivation for the work. Uncertainties are generally involved in every part of the system structural load environment, and we have to consider these uncertainties for probabilistic assessment of engineering systems. Random response Z is function of basic random variables or random fields assembled in vector X. And the function Gx represents a computational model which can be quite simple formula, but it can be very, very time demanding, complicated computational model. But generally, we are interested in statistical analysis, for example, calculation of mean value of the deflection of the cable state bridge, or standard deviation of the ultimate capacity, etc. We are interested in reliability analysis. If the limit state function represents the safety margin, we need to calculate the probability that safety margin is negative. And in this process, sensitivity analysis, which can distinguish dominating and non-dominating random variables in the process, is very important step. Once again, I have to emphasize that very often we deal with computational intensive problem like nonlinear finite element analysis, for example. So this is the reason that some small sample simulation of Monte Carlo type technique is necessary. And very efficient technique is stratified sampling called Latin Hardloop sampling, especially technique where distribution functions of random variable are divided into interval n sim, where n sim is number of the simulation of the same probability, and 1 over n sim. And the samples are generated by inverse transformational distribution function as representative value from the interval. Very efficient technique is just taking mean values of each interval, so interval centroid, so which is represented by these formulas. And in this case, actually, the mean value, because it's consisting of mean values, are simulated more precisely. Well, sample averages equal exactly the mean values of variables. Variances of the sample sets are much closer to the target values compared to the other selections. Actually, for some probability density functions, like Gaussian, exponential, etc., the integral can be solved analytically, but we have other probability density function where we have to do integration, but it's definitely worthwhile. Well, this stratified sampling was implemented in software which was developed in our group called Fleet. Is a multi-purpose probabilistic software for statistical sensitivity and reliability analysis of user-defined engineering problem. It allows to simulate uncertainties of the problem at random variable level, typically in civil mechanical engineering. Just very briefly, a few windows. This is a random variable window that there is a graphical user environment friendly, about 30 probability distribution, mostly 2-parametric. Some of them are 4-parametric, and there is some PDF calculator, right? Of course, we are able to work with statistical correlation among random variables and limit state function or response function. So compression model we want to analyze can be implemented in several different ways. Closed form in equation editor for simple problem, or dynamic library, or there is a general interface to third-party software. Well, the reliability window actually shows histogram of output variable after uncertainty propagation. An important step in the process is sensitivity analysis, which is telling us about dominating and non-dominating random variable implemented in the software, right? These are probabilistic techniques implemented where sampling technique, especially R-cube sampling, is the major technique there. I will not go into detail here. So basically, uncertainty propagation is, let's say, in agreement with sensitivity analysis concept. So we have a space of random variables, and we propagate these random variables to the response. And in sensitivity analysis concept, we want to have answer how these random variables X influence the input GGX, right? So very simple and straightforward concept or technique of sensitivity analysis is non-parametric rank order based sensitivity analysis. It's based on non-parametric rank order correlation between input variables and response variable. It uses already statistics invented like Kendall-Tau or Spearman coefficient of correlation to these formulas, right? Actually, you can see this in this table. There is a variable values, for example, X and Y, and simulation in rows, and the result is the function. So these are absolute values. So in case of non-parametric rank order correlation, we switch from absolute values to the orders, to the ranks. So these red values, and these ranks are used for these statistics for calculation of rank order correlation, because it uses only ranks, so it's very robust. Okay, and it's not so sensitive to the defect of the data. It's actually additional result of related R-cube sampling simulation, so no extra effort is needed. Bigger correlation coefficients means higher sensitivity, and there is a relative measure of sensitivity from -1 to 1 actually. Another type of sensitivity analysis is covariance-based sensitivity analysis. It's based on ratio between coefficient of variation of selected basic variables and the partial coefficient of resistance. But for the case that selected random variable xi is the only one treated as random simulation process, and other variables are kept at deterministic values. Then relative influence is just this ratio, right? And it requires additional computational effort because we have to treat every random variables individually. For k basic variables, the overall coefficient of variation of the resistance can be calculated based on this formula, and we can see that absolute influence of the variables is actually there is a contribution of the square root of COV Ry. This is partial coefficient of variation. So in such case, we can answer what is the absolute influence of variable xi to the coefficient of variation of the resistance. Additionally, we developed also another software which is called Sension Solver. It enables simplification of sensitivity analysis of user-defined problem. It utilizes the free software, but in a much more efficient way. Also, input perturbation-based analysis are implemented additionally. This is described in the paper. And the main advantage is that this software has node architecture which allows easy implementation of third-party softwares, which is sketched, let's say, schematically in this picture. So finally, I will show you some practical application. These are roof girder beams produced actually by Austrian company Oberdorfer. There was a big research behind. You can see the large-scale test and pattern from the test. And on the right side, you can see a numerical model. Which has been developed in finite element program Athena. It was not so easy. Actually, the mesh components of almost 25,000 finite elements, and because it was nonlinear, so it takes really a lot of time to calculate one simulation, about 4-5 hours, right? So in the process, in statistical simulation, there are a lot of random variables like modulus elasticity, tensile strength, compressive strength, fracture energy, also steel reinforcement, press-tracing tendons, modulus elasticity, yield strength, and also press-tracing force, which plays quite significant role, and loss of press-tracing. So all these random variables were considered in stochastic model in statistical analysis and for sensitivity analysis. And the probability distribution function has been extracted from experimental test and from the literature measurement. Well, in order to be able to perform sensitivity, our software was combined with finite element software Athena under the umbrella of software SARA. And this is actually the result of 31 simulations where there is a ultimate capacity, force, deflection diagram, and these limiting values actually represent the ultimate capacities of the girders. You can see there is a big scatter influence by a random variability of the parameters, and we wanted to know how parameters influence this capacity. So what are the most important? So some sensitivity analysis result. Just here you can see non-parametric rank order correlation, which represent relative sensitivity. The most important parameters are fracture energy, tensile strength of the concrete, compressive strength of the concrete, and modular elasticity of concrete, and other parameters are here. These are relative, but in absolute sense, sensitivity based on coefficient of variation will tell absolute influence. Or full stochastic model, we can see that this blue, the concrete is mainly the main, let's say, contribution on the press-tracing steel and tendons, and EVC influence of the concrete. So the major influence is fracture energy and then tensile strength here, right? So we did several analyses. Something more is also explained in the paper, but just for illustration, I think it's enough, this practical calculation. Sorry. So concluding remarks, I try to present simulation-based analysis technique which can be easily used to real-world structural engineering problems. Efficiency is emphasized using the stratified Platinum cube sampling simulation technique, which is efficient for time-consuming problems. Methods were combined in Fried and Scene software, briefly presented. And this presented software tool may be routinely applied to any problem in advanced design and assessment of engineering task. So thank you for your attention, and I'm looking forward for possible questions.
Sorry. Okay, thank you. And now it's time for questions. Do you have any question? Any of you?
Sorry.
Okay, if there are no questions, I got one very fast also, and
I have a question.
very easy. Ah,
Yeah,
sorry,
okay.
you have. Please ask you.
I see that the software thread is there is a free version which is limited, and I see on the internet that the limitation are not about how. Is it limited in time also? The free version of thread.
Well, okay. So I didn't understand fully your question. So what kind of so Fried is general simulation software, and of course it's limited. The time consumption depends on response or limit state function you are treating. If it's just simple functions, so you can perform millions or billions simulations, right? But in case of time-consuming problem, like I showed this jether, it took maybe 6 hours one simulation. So then we are very limited, and we can perform. From practical point of view, we can perform really tens or hundreds simulations, and we want to still to say something about reliability, sensitivity, etc. So we have 100 users worldwide, and users actually use it for different class of problem. So yeah, so this is what you ask actually.
It was about is there any limitation for the free version?
Limitation for free version. I see. So you can download, let's say, demo version from our web pages, right? You can, but there are some limitation imposed concerning the probability distribution, and also you cannot save your task, right? So this is a, let's say, demo version you can freely download, right? So in case you are interested in, just communicate with me, and we can find some solution, right?
Thank you.
Okay, thank you. Any other question? Okay, then thank you very much.
Thank you.
And let's go to the last work. Data value as basis for human behavior modeling. Is here? Yes, Antonio. Okay.
Hello, everyone. This is the paper of Professor Agostino Bruzzone, but it's another special session. So if you agree, I can share the video.
Sure.
Okay, just 1 second, please. Okay, 1 moment. Sorry, 1 moment. I have problems with the video.
If you have problems, I can try to do it.
Yeah, I think yes, because it doesn't start.
Or Antonio Padovano can do it because he do it. He does it very well.
Yes, Antonio, don't worry. I can share the video.
Sorry.
No problem at all. Here we are.
Perfect.
I can start now.
Hi, I am Professor Bruzzone. I will present today a research we carried out at Sim4Future, that is a spin-off of Chen University and a proud member of simulation team. This research deals with the issue of evaluating the value of data. Data represent the value we know in the company, but in reality, data are even an asset. Financial assets could be a new way to look at them, and it's very important to define methodology and approach to estimate this one. Sim4Future received some project by private companies in order to address this aspect. Some of these companies used videos to finalize transactions that have legal value in some country and could be used for financial operations. Operations that are sensitive, considering that move from few $100,000 or dollar up to few millions, and it could be interesting to know if this kind of video, in respect of all the regulation, like the regulation for privacy in Europe, or even the regulations existing in the United States, could be available to have a value and even to be monetized and to have represent the financial asset of the company itself. There are different kind of issues to be addressed in this area, because one is about regulation and laws. Obviously, this is a major aspect. I will say that obviously the private data and the privacy cannot be exploited. Therefore, it could be possible to extract from this video information that could be useful for addressing understanding of behavior. For instance, if I use this video to understand how a person that is going to invest $1-2 million react to different proposals and how much time take to finalize the decision, how much stable and stood is on taking this decision, this is an added value to understand. Obviously, there is an aspect like that that is pretty interesting, not just about finance, but even about the person. So we identify how to split the value in different areas. Let me mention you how this works. Okay, first of all, in terms of the assets, there is a quite long scientific experience and even market analysis related to value of data in many sense that are, let me say, identity data, data related to healthcare, etc. That could go from few cents or part of a cent to significant amount of dollar. Obviously, we talk about few dollars or even $100 in some case. This is normally related to the fact to have a huge quantity of data and to be able to mine from this data information that could be useful. Obviously, if I can identify people to target for a product that I don't know is about dealing with head cake and identify that by how these people behavior they have this problem, I could sell some aspirin. Okay. I mean, this is quite invasive because it's invasive in terms of privacy and it should be important to respect the regulation. In this case, we are in a different areas because we don't deal with huge quantity of number. We don't have 1,000 or 100,000 or million of people investing $1 million in a transaction that take, let's say, between 5 to 15, 20 minutes. But if you want that we have a very reliable, very added value. It is interesting to know if these people could provide us a better understanding of the behavior using some artificial intelligence machine learning system to identify characteristics. These characteristics could be cross-linked with their identity, with their nationality, ethnic group, and so on, in order to be more effective in finalizing the transaction and in identify the interest of the person that we have to face of our customer in more effective way. Okay, I will not talk too much about the regulation because in this case we point out obviously all the analysis related how they have to deal with this element in order to respect the law in the different country, in the different unions, etc. Another aspect is vice versa to identify what we can extract from this video. And there are different things that we can extract. One issue is related to the video by itself. So image processing could help us to understand the movement of face, of eyes, the temperature. For instance, by camera, even with not very high resolution, but is a reasonable resolution, we can extract information about the pressure of blood on the face, as well as the temperature of the skin that could respond to emotional reactions. And as you know, in this case, very important emotional reaction to understand what is the real reaction to our financial proposal and to the deal and to the negotiation. So this is an aspect that we investigate. Another aspect is about voice, because voice represents by tone, it allows to understand specific sound, specific frequency.
Your microphone is mute.
Thank you again. I think that the video has finished. Well, it's time for questions. Is there any question?
One thing, I didn't take part in this project, but for any kind of question, please contact Professor Bruzzone by email.
Okay, perfect. As everybody knows him,
Yes.
maybe today is not easy to ask him because he's very busy, but for sure next week or before, for sure Agostino will answer any question. Okay, then thank you very much.
Thank you very much.
Okay, and thank you to everybody for coming here to this session. Remember that we have another section at 4 o'clock. At 4 o'clock, we have the second part of this session. Then have a good evening and see you soon. Bye.
Thank you, Emilio.
Thank you, Antonio. It's very easy with you there.
Always very good to see you.